Hello student, in the last lecture we have seen that the second article that is derivative of inverse trigonometric functions, and after that we also seen that there is a theorem of inverse functions and some important formulae for the derivative of inverse trigonometric functions. Now we take, by using this derivative of inverse function, we take exercise 1.2. So first question, find the derivative of the function y equal to f of x using the derivative of the inverse function x equal to f inverse y in the following functions. The first example, y equal to root x. So here we have to find the derivative of this function y equal to root x by using its inverse functions. So given y equal to root x, then we have to convert it into this function into its inverse functions. So this is x equal to y square. First of all, here due to this square root sign, we taking square on both sides, then it is y square, and square root sign it removes due to we take x square, square on both sides. So this is the f inverse of y. This is the inverse functions. Y square, x equal to y square is the inverse function, f inverse y. Now we take its derivative, or you may also write differentiate with respect to y here. Differentiate with respect to y because x is in terms of y. So the derivative of x with respect to y is dx by dy is equal to derivative of y square with respect to y is 2y. I call this equation is first equation. Now by using this equation first, this y is root x from 1 and so we have to find the derivative of y with respect to x by using this inverse function, means we have to find the dy by dx. Now we have dy by dx is equal to its inverse function dx by dy, and so therefore dx by dy is nothing but 2 root x 1 by 2 root x, and so this is the derivative of y with respect to x, means this is the derivative of function y equal to f of x in terms of its inverse functions, x equal to f inverse of y. Now we take the second example, which is similar to this first example. Y equal to root of 2 minus root x. Here again we convert this function y equal to f of x in terms of its inverse function. So again we take its square on both sides, taking square on both sides here. So y square equal to 2 minus root x. Then we take this root x in this side in the LHS, so which is root x, and in the RHS 2 minus y square here. Take this y square in the right hand side, that's why it is minus y square. Again due to this, since here it is a square root of x, so we take square on both sides. Whenever we taking square on both sides, so it is x equal to 2 minus y square whole square. Now this function, this is the inverse function. This is the f inverse of y. F inverse of y. X equal to f inverse of y. This is the inverse function. Now we take its derivative and find the derivative of y. Derivative of y equal to f of x. Differentiate with respect to y here, because x in terms of y. So the derivative of x with respect to y is dx by dy is equal to, here this function is like f of x raised to power n, derivative of f of x raised to power n. So that's why its derivative is here. First derivative is power into that function to the power minus 1, 2 minus 1, it is 1 only, into, by chain rule again we take its derivative. So the derivative of 2 minus y square, and so it is 2 into 2 minus y square into, so the derivative of 2 constant 2 is 0, and minus y square is minus 2y. Derivative of y square is 2y and minus sign is already there, and therefore 2 into minus 2y, it is a minus 4y into 2 minus y square dx by dy. Now we give, this is of equation first, equation second. Now we use equation 1 and 2 here. Minus 4y means from equation 1 it is root of 2 minus root x into 2 minus y square is 2 minus root x, and due to this minus sign, this minus becomes plus. Here plus 2 minus 2 will get cancelled. Now it gives minus 4 into root x, it is minus 4 root x into bracket root of 2 minus root x. This is dx by dy, but we have to find the derivative of y with respect to x, means dy by dx. Now we have dy by dx is equal to its inverse dx by dy, and it is equal to 1 by, so dx by dy is a minus 4 into root x into root of 2 minus root x, and so this is the dy by dx. Similarly, we take example number 4th, because example number 3 is again similar to example number 1st and 2nd also. That's why we take example number 4 here, y equal to log of 2x minus 1. Now example number 4th, y equal to log of 2x minus 1. Here first of all we use here rules of logarithms here. So we convert. So by the definition of logarithm, suppose here if a, x and m are the real number, then a raised to x equal to m, if in this form, then this x is called as log m to the base a. X is called as log m to the base a by definition of the derivative. So this is the definition of logarithm. Definition of logarithm. So our form is here logarithmic form, so we convert into exponential form here. So that's why In natural logarithms, to the base e is already here. That's why we convert this log into exponential form. So it is e to the power y equal to 2x minus y by using this definition of logarithm, because e is to the base e is here, log to the base e is here. Now again we take this minus 1 in the right hand side. So e to the power y, it becomes plus 1 equal to 2x. Again take this 2 in the left hand side. So e to the power y plus 1 by 2 equal to x. Therefore x equal to e to the power y plus 1 divided by 2, and which is of the form f inverse y. This is in the form of f inverse or inverse function. Now we take its derivative. So differentiate with respect to y. So we get, so the rate of x with respect to y is dx by dy, and here 1 by 2 is a constant, take before the derivative, and we take the derivative of e raised to y plus 1. So 1 by 2 into derivative of e raised to y is derivative of e raised to y with respect to y is e raised to y. It is an exponential function. The derivative of exponential function is e raised to x is e raised to x, same as derivative of e raised to y is e raised to y, and derivative of constant 1 is 0. Now this is e raised to y by 2, but e raised to y is from this equation, from 1 e raised to y is nothing but 2x minus 1. E raised to y is 2x minus 1. 1 by 2 into 2x minus 1, and this 2 will get cancelled. It is x minus 1. Or also here put it as it is here. Now we have, but we have to find the derivative of y with respect to x. Here it is inverse, that's why we have dy by dx is equal to 1 upon dx by dy by inverse function, and so 1 by, it is a 2x minus 1 by 2 here. Take its reciprocal, so therefore dy by dx is equal to 2 upon 2x minus 1, and this is the derivative of y with respect to x. Is again there is a next example number 5, which is so simple, y equal to x plus 3. That's why we take example number 6 here. Example number 6. Y equal to e raised to x minus 3. E raised to x minus 3. Here our function is in the form of exponential. Again we convert it into logarithmic form because we take its inverse function. So therefore, again by using this definition of logarithm, so whenever a raised to x equal to m, then its log is here, logarithmic form is log m to the base e equal to x. Means first of all we take this minus 3 in this side and it is e raised to x. Now here we convert it into logarithmic form. So it is x equal to log of y plus 3 to the base e. So there is no need to write to the base e here. So it is log of y, x equal to log of y plus 3, and this is inverse function f inverse y. Now we take its derivative, differentiate with respect to y, we get. So derivative of x with respect to y is dx by dy is equal to derivative of log of y plus 3. So its derivative is here 1 by y plus 3, and by chain rule again we have to find the derivative of this y plus 3. So 1 by y plus 3 into derivative of y with respect to y is 1 plus derivative of constant is 0. So it is only 1 by y plus 3 dx by dy. But we have to find the derivative of y with respect to x. So now we have dy by dx equal to 1 upon dx by dy, 1 upon, but dx by dy, derivative of x with respect to y is 1 by y plus 3, 1 by y plus 3, but y plus 3, write equation 1, but y plus 3 here it is e raised to x. So 1 by e raised to x, and so it is e raised to x. Therefore dy by dx is equal to e raised to x, and this is the derivative of y with respect to x. Now the example number 7 which is similar to example number 6, and the example number 8 is similar to example number 4. That's why you may try to solve at home. Now we take second question of this exercise. In the second question there are 5 examples. These are similar. So first 3 examples are similar. Here we have to use the rule for u into rule for the derivative. Also fifth example we use u into u rules, and the fourth example we use the first rule u plus v. That's why we take example number this first and fourth here, and you may try to solve at home the example number second, which is similar to first, third also, and fifth also. So the example number first, y equal to x square into e raised to x. So given let, or directly we have to find the derivative of the inverse functions. Yes. Now we take this first example, y equal to x square into e raised to x. Let actually this given function is in the form y equal to f of x, and then its inverse is x equal to f inverse y, and the derivative of this f inverse y is f inverse y is here dx by dy, and so therefore our given function, we find its derivative of the inverse function by using this function y equal to f of x. So x square into e raised to x, our given function. Differentiate with respect to x, we get derivative of y with respect to x is dy by dx is equal to, here we have to use u into v rules, product rule of derivative. So the product of rule of derivative is here, derivative of u into v is equal to u as it is into derivative of v plus v as it is into derivative of u with respect to x. By using this rule here, we apply this rule here. So this x square is u and e raised to x is v here. So therefore by using this rule, first function u as it is, x square as it is into derivative of second means derivative of e raised to x plus second function as it is means e raised to x as it is into derivative of first means derivative of x square with respect to x. And so x square into delta of exponential function e raised to x is e raised to x plus e raised to x as it is into delta of x square by using delta of x raised to n, it is 2x. So from these two terms we take common e raised to x and x also. So x into e raised to x we take common, so it remains x plus only 2. So this is the dy by dx, derivative of y with respect to x, but we have to find the derivative of inverse function. Now we take its inverse, means dx by dy is equal to 1 upon dy by dx, and which is equal to 1 upon dy by dx is x into e raised to x into x plus 2, and this is the delta of inverse function x with respect to y. Now the second and third is similar to equation example number first. That's why we take example number fourth here. Now we take example number 4, y equal to x square plus log x. Again, actually this function is in the form y equal to f of x. Its inverse is x equal to f inverse y, and the derivative of f inverse is dx by dy, means we have to find the dx by dy in this function, in this question here. So but our function is given y equal to f of x in the form, therefore y equal to x square plus log x. So differentiate our function y in the form x, that's why we differentiate y, differentiate with respect to x here. Therefore derivative of y with respect to x is dy by dx, and here we use u plus v, derivative of rule of derivative of u plus v. So x square plus log x, so u and v, derivative of u, so it is the x square, derivative of x square plus v, derivative of log x. So derivative of x square is 2x plus derivative of log x is 1 by x. So we simplify this, x into 2x, it is 2x square plus 1 divided by x. This is the derivative of y with respect to x, but we have to find the derivative of x with respect to y. We have to find its inverse function, its inverse. That's why we have dx by dy is equal to 1 upon dy by dx is equal to 1 upon, but dy by dx is here 2x square plus 1 by x plus 1 by x. And this is, take its inverse reciprocal, x upon 2x square plus 1. This is a inverse function. So in this way, next example, which is similar to example number first, second, third, that's why you may try to solve at home. In this way we complete the question number 2 in the exercise 1.2 here. Today we'll stop here.